Okay. I think we hit the 5:40 button, so maybe let's start. I think we can squeeze everybody into the room. We're just able to do that. So welcome. You have managed to end up in the OPSEC working group. So the first two things we need to figure out here is who is willing to take some minutes, so like a volunteer. Not everybody together. Eric, you? Awesome, thank you. Anybody willing to do Jabber stuff? Jabber scribe? Going once? Jabber? Okay, thanks. So everybody knows the note well. The blue sheets are going around just to make sure that the next time we get again a room which fits everybody, with the large numbers we are here, and let's have a look into the agenda. So this is the note well. You've already seen it a few times. Just make sure that you read it and that you understand everything which is in there. Blue sheets, important. So where are we right now? So there was no OPSEC meeting at the previous IETF. The main reason is because it was relatively quiet on the email areas and not really that much new work was kicked off. Now, nevertheless, since IETF 90, we managed to get like 3 RFCs published. So that's reasonably good. We also have one document which is right now in the ISG processing. Fernando is on top of that one. That is being, being dealt with pretty well. Maybe a question on the mic too, because we have Joel there.
So the document still has one discuss, which so far we have not been able to agree with the AD on how to proceed. But as far as I understand, they are changing the ADs or some of the ADs this week. So I guess we will have to discuss that with the incoming AD.
Yeah, let's do that. Sounds a good plan. Then another document will be progressed further on. So that is waiting for a Shepherd write-up. That's me, still on my to-do list. And also we have the wonderful enjoyment about IPR disclosure for one of the documents. This was done by Cisco on RFC 62192. So that is being dealt with also somewhere in parallel in the background. Like control plane policing or something like that. So this is where we are with the agenda. We started a couple of minutes late. Then we have 20 minutes for Eric. And then followed with 2 slots for Fernando to speak about extension header filtering and about ICMP ingress filtering. So let's start. Eric? Yeah, so the speakers have to be in pink thingy.
And this one is pink, at least.
Yeah, looks like pink.
Purple or whatever. Anyway, so it's a very long presentation. Let's start immediately. So there's an update on the draft that we started a long time ago regarding the functional procedures to operate securely in a IPv6 network. So Mary Kay and KK are the co-author. I'm the last one. And since last IETF, there's revision actually. Nothing is moving. Huh? Okay. So what we did, basically refresh the references because a lot of draft from Fernando has become now RFC, so we needed to change this, change a few wording, fix typos. As I'm a co-author, my co-author fixed my English, so things were improving. Next. And now the to-do list. We just need to ensure that we started this work in 2012, so that's 3 years ago. We have security, as we all know, is a moving target. It's an ever-changing field. And as Fernando is there on the first row, cannot say that, hey, you are finding other bugs, so we need to update our document every year, so stop working. So we will get a left moving target. Joke, of course. So now, we were working now for more than a year, the three of us, the authors, to basically push this document, which was ready at 95%, and basically it's three authors, so it's three parts of text, and we clearly use sometimes different vocabulary, different style, and we wanted to get a document which was nice from the English and readability and clarity point of view. But basically, to be honest, and I think Mary Kay will agree with me, we are running out of steam. Because going from 95 to 99 is okay. Going from 99% to 99.9% completion takes forever. We sincerely believe that what's inside, and we got multiple comments already 1.5 years ago, when the document was active and hot, is mostly complete in the sense of citing and doing all the aspects and all the issues and proposing mitigation techniques. It's not finished regarding readability. What we really believe document is finished, right? So we really say this one should go for last call. Now, if we find issue in the last call, obviously we'll fix them, right? But the authors believe that we are really, really ready. And we should have done this a year ago, basically. And the next slide, I think it's, yeah. That's it. Maybe you want to say something, Mary Kay?
Yeah, a bit of clarification also. So there were a number of meetings, even the RSA conference that, we were both at. And so we'd sit down and do some wordsmithing. And one of the things that we realized is that this document really is a comprehensive look at, I think we have at least 80 RFCs referenced, right, that deal with any kind of security. Yeah. And so we believe that the content is all there. We were trying to wordsmith it and kind of make it aesthetically a little more cohesive. But the last time we looked at it, we felt that, it may not actually be necessary. So for us to be spinning those cycles, and, we're all involved in a lot of different work, we felt that it probably was actually ready for last call. And then if people had an issue while it was in last call, then that's the time that we would spend on fixing anything that was really glaringly either wrong or missing.
Yeah. Okay, so just to get a feel of the room here, who actually has read this document? Okay.
Thank you.
Okay. So something what I've seen also, which was happening like in another document for going to like 100% completion was nearly impossible, was the BGP filtering element.
Mm-hmm.
The way they circumvented it is to refer to particular, references, to take those things into consideration to make the document actually more static. Is that maybe something you can look into also?
It's not so much the references that are changing, because honestly, it takes some time to change all the ID into RFC, that's for sure. But we are adding sometimes new fields. For instance, at Troopers conference, that a couple of us were, we'll get something like MLD's issue. Most probably some place to write another ID, but we will not update our document because it's takes forever.
Yeah.
And it's already contain a lot of things in running operation.
Okay. So I think out of the room, like 3 people actually have read it. So what maybe before going to working group last call, actually, is there like people in the room willing to give this, a read of the document, give them, the feeling about how ready it is before we go to the, the next step of. Yeah.
It's 15-20 pages, as far as I remember.
Fernando, I recall going through the document, but a long time ago, and for me at that point in time, it was already in pretty good shape. Usually, in my experience, what at times happens is that when the document goes through working group last call, it's when you get more people to read it. So I don't know if that's the way to go, but that could be among the possibilities, right?
Okay. Cool.
Okay. Thank you.
This one.
And so, Fernando, I'm present. Okay.
This is the one?
Well, but again, it doesn't matter. Okay. So this is mostly an update on the document that we wrote about recommendations on filtering of IPv6 packets containing IPv6 extension headers. Next slide. So this is essentially a document that is an IPv6 version of RFC 7126. At the time we published a document on the filtering of IPv4 packets containing IPv4 options. So this is an IPv6 version of it. The ultimate goal is that to some extent this document might help with improving the current state of affairs when it comes to the packets being dropped as a result of containing extension headers. It tries to summarize security and operational implications of extension headers and IPv6 options. This is again like the same thing that we did for RFC 7126. So for each extension header and option, we try to summarize what that header and option is used for and what might happen if for some reason you were to drop packets containing them. And then what we try to do also is to provide advice to what to do with, with each extension header and option type. Next slide. So this is the change log since the last revision of the document. One of the things was that we clarified that we assume that the rules in RFC 7045 are in place. Then regarding the hop-by-hop options extension header, if I recall correctly, the previous version of the ID essentially just advised it to drop packets containing hop-by-hop options. And based on working group feedback, what we did is modify the advice and say that, well, if the platform can process hop-by-hop options in the fast path, they should pass the packet. Otherwise, they should rate limit those packets. But if the first option and the second option are not available, then as a last result, they should drop those packets. And another thing that we clarified was that, and that's essentially the same discussion that we had for RFC 7126, is that we are not really specifying configuration defaults, but actually providing advice on how to configure devices. That's essentially what we believe was at the time already the IETF consensus. So in those cases in which we are, let's say, advising to, let's say, rate limit or drop some packet, it's not that we are advising implementations to ship with our advice by default, but they should have their own, their own defaults, and then the guy manually configuring, the device should probably follow the advice that we are providing here. Next slide. So what's in our to-do list? I don't know if it was Jen that had suggested this a while ago. We will try to produce a summary table with a summary of the advice. I think that, a couple of people had mentioned that, having to go through the entire document and look up for the advice was not that nice. So it would be great to have a table that just, mentions the advice, and if you want, if you want to look for the rationale for that, you can do it. There are quite a few sections that are mostly placeholders, okay? The reason, of course, is that we're covering all the extension headers and options, and some of them are at times hard to find what they were specified for and what they are used for, etc. So that's the other thing that it's in our to-do list for the next revision. And I don't know if there are any comments or whether we have missed anything. Among other things, if there's anyone willing to to take a look, not just in detail, but if at the high level order there's something that we are missing, we would like to hear that so that we we update the document accordingly without finishing all the details. So I guess we can. If there's any comments, just either contact us or post that on the mailing list. The idea is that if there's any high-level change that is required, we apply that, as soon as possible, as opposed at the late stage. I think that's it for this one.
Okay. Just out of interest again, also, out of the room here, who read this document actually? 1, 2 people. Okay.
Jen Linkova. I read the previous version and I just tried to look through the current version of it. Yeah, I probably will put some comments on the list. My first impression, I don't know. I read it and it looks like you quite often say device should drop. I don't know if you should say your policy should not permit this or something like that. Because it basically, for me, I have to go to the beginning and double check that we explicitly say this is not default configuration on the device, this is recommendation for a policy. But all text in the document that say device should by default drop this. So probably we should make more clear, like we're talking about policy, not about what forwarding device does with that packet.
Okay.
And another issue is, do you think we might need to separate advices for like transit network and situation when you protect your own network?
That's up to the working group.
So I think it might be useful because I read it as like forwarding device should drop that, and that, but probably you don't care if you're just a transit provider. Probably you do care if it's your network and you're protecting it, and you apply these firewall rules on your router. It might be your approach might be completely different.
Yeah, that's actually that we'd like to hear from the working group, because we have even talked, among the co-authors, and some of when we were talking about this idea, some were suggesting to say, well, kind of like that, to make a difference between a transit router from another one, and but we were unsure about that. So that's up to the working group.
Jean-Michel Combe, if you are a transit provider, you care with the up-by-up option.
Yeah, I just took a real quick look at the document, and hearing Jen's comment and from the gentleman behind there, I also think that looking at specific different use cases like transit providers or otherwise would have different implications, and so I would probably add that language in, but I also promise to read it in detail actually and put some comments on the list.
Awesome.
Thank you.
Next one, I think.
Next one, okay.
Okay, so this is a presentation about the document that we wrote on network ingress filtering, defeating attacks which employed forged ICMP error messages. As a kind of background, a while ago I was working on essentially on a document about attacks that require spoofing ICMP error messages. The idea was quite simple. If you were to spoof ICMP packet-to-big error messages claiming an MTU smaller than 1,280, you could trigger the use of fragmentation, okay? And then as a result of the network filtering fragments, then that would lead to a denial of service. I mean, the background is not needed, but I'm just explaining how we got into this document. This stuff was discussed in the V6Ops mailing list, and a few folks suggested or we started discussing how we could possibly filter ICMP error messages to mitigate these attacks. So this is what this document is about. Next slide. So essentially, if you look at BCP38, it's about mitigating attacks that require the spoofing of the source address. But this BCP38 doesn't address ICMP-based attacks, because when you spoof ICMP error messages, you don't really need to spoof the source address of the outer packet. You need to spoof the source or the addresses on the packet that is embedded in the ICMP error message. Okay? Next slide. So this is like a very small refresher. So let's say that we have host A sending packets to host D on the other side, and then this router finds that there is some problem. It will send an ICMP error to host A. So the addresses that you will get is in the source address, address B, of course, which is the source, destination address, address A, which is the destination of the error message, and then in the payload, you will get a chunk of the original packet. Of course, the original packet was directed from A to D, so in the source you will find A, and in the destination you will find D. Okay? I mean, no magic there. Next slide. So this could be an attack scenario in which you have some networks in there. And the idea in here is that you have this attacker in some point of the network that wants to attack the connection between these two systems, okay? So the idea is that the attacker that is connected to the network at some random, let's say at some random part of the network, wants to attack the connection between these two guys. Now the problem is that when this attacker sends a spoof ICMP message, it doesn't really need to spoof the source address. Why? Because error messages can come from any router, so you don't need to pretend or impersonate any specific router. So in this case, if we are attacking, for example, the connection between these two, and you are sending the error message to this guy, the source address, you can use your own address, this one. The destination address is going to be the target of the attack, that is this one. But the addresses that you are really spoofing are the two addresses that are in the embedded payload, okay? Now, if you look at the error message from the point of view of this router in here, there's nothing wrong with the addresses in here, but when you look at the addresses that are in here, I mean, it's clear that, the error message cannot really come from this side, okay? So this is essentially like doing ingress filtering, but rather than looking at the addresses of the outer packet, you are looking at the addresses that are embedded in the payload, okay? Of course, let's say if we have the source address, which is so if it's clear that a packet that comes from the internet, in this case, assuming there's a single connection, of course, could never have these addresses, in the embedded payload. So you could do ingress filtering by looking at the addresses in the embedded payload. Next slide. So this check is essentially an extension to BCP 38, and the advice is actually in line with BCP 38. Next slide. And these are the rules. We are stating them in the same way as in BCP 38. When you look at the address that is in the destination address of the embedded payload, that is not the outer packet. Can you go back choose? Yeah. So you're looking at the embedded packet in here, right? So this is the outer packet. No need to look here because the addresses here are not going to be spoofed. These are the addresses that are going to be forged, okay? So, two more? Yes. So you look at the destination address, and if the destination address of the embedded payload is from your network, you forward the packet, and well, you do essentially ingress filtering based on the destination address of the packet that is embedded in the payload, okay? So in the same way as you do ingress filtering on the outer source address, for the ICMP error, you do the same thing on the destination address of the embedded payload. In the same way and in the same case as in BCP 38, in the same way that you can do this, you can do the same thing with universe reverse path forwarding. Yes?
You mean source address?
Let me see.
The source address in the embedded packet.
You're right.
Because if you take your figure.
Yes, you're right. Yeah.
No. Because if the guy wants to go to the internet, if they want to go to the
Can you go back a couple of them?
Because you put your ingress filtering on the first router.
Yeah. No, actually, you look at the destination address, because this means that, let's say, if you are receiving an error message from here, so the filtering is happening here, okay? So that means that if a packet is coming from here, that means that this router eventually sent on this link a packet destined to this destination address. So that's impossible, okay? So that's like BCP 38, but just on the embedded payload. So from the point of view, so in order for this error to be legitimate, eventually this packet should have come up through this link, okay? Now when you look at the destination address, it is impossible, okay? So, so this is a check that you can perform on any ICMP error message. We think of this check as an extension to BCP 38. Of course, it's different to check on the source address of the outer packet as opposed to the address that is embedded in the payload. So there might be cases in which you could do like traditional BCP 38, but not look at the addresses of the ICMP error. But again, this is an extension to BCP 38. Next slide. So I don't know if there are comments.
Yeah.
Sure.
Yeah. Jen Linkova. I'm afraid it's gonna work in very particular scenario for single link, no multi-homing, nothing, because just imagine you have multi-homing in this case. Nobody could promise you symmetric routing in the internet.
But isn't this the same? I mean, isn't that the same thing as for BCP38?
No.
Why not?
No, because you can. Okay, could you please show picture? Yeah. So basically, this machine on the left.
Yes.
Yeah, it might have dual connection and send packets to the internet somehow, yeah, which will be coming back through another link. URPF is dangerous, yeah. You can enable it in very specific, topology, yeah. In all other cases, it's just causing traffic blockhauling, yeah.
Yeah, exactly. So what I'm saying is that the constraints for applying this are essentially the same constraint for applying BCP38 of URPF. Essentially the same thing.
I'm really concerned that if you start doing this on router, it's going to be dangerous. Because ISP, let's say, start enabling this on the router, and then this network on the left getting dual connection, and then they have to go to ISP and explain to them that their configuration is causing traffic blockhauling. What you're talking about is actually deep packet inspection. It should be done on firewalls in very specific scenario close to destination.
Yes.
It shouldn't be done on routers.
We're actually in this document, we are not actually saying on which kind of device you should enforce this. Actually, as you say, probably in a device such as a router, you probably not do this. But for example, on a CP, you could easily do this.
HomeNet? Theoretically. So I think as soon as you get in dual connectivity, especially in case of V6.
Well, but isn't that the case for BCP38?
No.
Already?
No, because in BCP38, you should always send traffic with a proper source, but reply to some packet which might come to you through completely different link might be sent through another link.
What do you mean a reply?
So you receive packet through one link and you send answer as this ICMP through another link because it's how your routing works in your network. Yeah, BCP is protecting you from sending packet with the wrong source, and you can control this. So
but in this case, for example,
we need a whiteboard next time.
What?
Whiteboard. I think we need to draw some pictures here. But believe me, as soon as it's routing, and it's not like firewall close to you deems that when you're absolutely sure there is no backdoor to your network, this is not going to work and it's going to be dangerous. So I think it should be done on firewalls as a part of deep packet inspection or whatever, and not as like any recommendation related to BCP38.
Okay.
It's my opinion. I'm horrified. Seriously. The only good thing nobody gonna do this because they couldn't look deep enough.
I understand why you're saying that it's kind of like BCP38, but the problem, I think, is the fact that you have to look deeper into the packet. And what I'm trying to think of now is, this is true for any error messages for any protocol that can actually say, hey, the error message is actually coming from a quote-unquote spoofed source. So while I think this is interesting, right, and I mean, people may need to be aware of this, I am squinting because I'm worried that this can be misconstrued. Okay.
What do you mean misconstrued?
Because if this document is out there, that means that, oh gosh, we should do something about it. And what you're going to be doing is deep packet inspection on absolutely everything, and from where? On the CPE, on the router, on the firewall, what? And so I have to think about this a little more. But I mean, it's.
Well, at the firewall, you'd probably do it anyway. So.
For every error message, I don't know. Yeah.
I think I forgot. I think I don't remember if we discussed it when we were talking about fragmentation header, and this is host problem. It's a host which is broken because the host should verify, have I sent this packet? What is inside behind this IP header? Do I have actually any TCP session which match what is going on, what I received? We should fix host implementation if this attack is actually possible, not trying to break routing.
Well, there are actually two comments that I could make about that. I'm not saying that what you're saying is not correct, but there are a couple of problems there. So first problem is that since the extension header chain can grow as much as you want, then you are not guaranteed that in the embedded payload here, you are going to get a TCP header.
It's true for basically every single ICMP error message. What we're supposed to do if you could not identify the sessions is ICMP.
Unfortunately, nowadays, you accept them.
Again, then we probably should fix this. We probably need some recommendation on how to what to do with processing ICMP error messages on the host, instead of trying to fix every single possible attack scenario on the network level when host is stupid enough and not properly checking if it's valid ICMP error message or not.
There are two things. So first thing is that in theory, you are not guaranteed that you're going to get, for example, the TCP header here.
Okay.
Because since the original packet, since you, same thing as always, right? Extension headers, you might get as many as you want, and since you only get like a chunk here, for example, let's assume that you have a packet that has, let's say, 1,300 bytes in headers, okay? And then after that, you get the transport header. The chunk that you're going to get here is going to be 1,280, and it's not going to contain the transport header.
Again, let's then discuss what host should do in this situation. Because if it's attack, it's targeted to the host, and it's host check which should deal with it.
Well, now we get to the second item. I tried exactly that 10 years ago. That's RFC 5927, which took me 7-8 years. And while I agree with your view, let's say that TCPM didn't agree on that. That's why when you look at the ICMP specifications, they kind of like say, well, you should look at 5927, but they kind of like, they don't recommend anything because TCPM wasn't that much in favor of that.
Did I get it right that we are trying to fix not what is broken, but things which we could fix? Because we are able to do this?
I think, to be honest, I think the two things are orthogonal. So I think that when it comes to the validation on the client side, that's something that should be done. In many cases, it's not done. The simple example is Linux. The only thing that you need to, to guess to perform any ICMP-based attack on Linux is just the endpoint addresses. I tried that, and you don't need to even put a valid protocol inside. As long as you get the right addresses, that's as much as that's everything that you need. So that's one part of it. So they currently don't, they don't perform that validation. And on the other hand, I agree that you wouldn't do this sort of thing in any arbitrary devices, but there are some in which you can do this kind of stuff, and that prevents the systems that are behind the device where you are doing this filtering, that you prevent those devices from performing attacks against other systems on the internet.
So basically, to summarize, I believe the damage which could be done, comparing to damage which we are trying to prevent, is much bigger. So we trying to cover one very specific particular use case and trying even to fix it from the wrong side, not where it's actually broken, and we give people ability to misconfigure their networks even more.
So Jen, you basically said what I was about to say about the host verification. Now, most of the firewall do it. It's not basically DPI. They simply look about the state, if they have a TCP connection on this, because they need to know. So stupidly, a 4 firewall can do it. And I see an ICMP coming back with no matching, then I can drop it. Now, if Linux is buggy, Linux should be fixed, though.
Yeah.
Honestly. And because, don't forget, right, ICMP error messages are critical for debugging. And there could be some case, and we have seen this, right? VPN, for instance, from the top host to the internet and sending the traffic back. And this is, of course, abnormal. It's an error. It's a mistake somewhere. But we should get this ICMP message. So I think the mitigation technique is worse than the disease.
The mitigation technique is what?
The cure is worse than the disease if we apply this.
But so you are talking about a scenario in which the network is multi-home?
No, I'm simply, my point is that ICMP, this is mainly to detect errors in an operation.
Yes.
If we block this, even good packets indicating an error because there's been some misrouting or whatever, or we will not see them.
Or put another way, could you come up with a scenario where BCP38 wouldn't be breaking the network and this stuff would be?
Yes. Okay. This nice host on the left. Just let's think about V6 because it's going to be simpler. And as this multi-homed host, I have two duals, like two connections to ISP. And I'm sending some packets to host on the right through the second link. Right? And for some, again, multi-home increase, and the host might return packets through the internet, ICMP packets to internet. Right? So basically, your scenario works only because you have one single link from each host to the router and one link to internet. As soon as you're adding multi-home and ability for packets go in asymmetrical, you could not guarantee anything. And BCP38 would work because packet from host on the left will have proper source.
Yes.
But the host which...
But what you're saying is that this node, for example, has two links, just to check if I understand what you're saying. So you are saying
it's going to be one prefix. Yeah, it's going to be one prefix.
So it sends the packet from this source address to the network.
Yeah, sorry. It should be multi-home, but still with one source address, using the same source address. But packets from the host and packets to the host might come in through the different links.
So only one source address, or
yes.
only one address, two different links.
Yes.
But in that case, I mean, when you were to apply that filtering to on this router, then it should allow them on both links.
It might be completely different router somewhere, right? It's two different routers.
Well, this is stuff that I would apply at the edge. So if you are talking about, some random router in the network, that's like a different scenario.
You are an ISP, right? You don't know you don't necessarily know what's going on with that host. The host might get another uplink to another ISP. I can remember a lot of cases when transit providers turned on URPF and black hole my packet. And when you came to them, they said, oh, it's security feature. Well, we write recommendations. It's a very good idea. I'm not going to turn it off. Your packet's black holes. I don't care.
But that's exactly what I was saying. So exactly BCP38 or doing URPF was breaking the network in that case, and this is the same thing.
URPF is breaking. BCP38 is different.
Yeah.
Because BCP38 has nothing to do with asymmetrical routing, but URPF does. URPF doesn't work properly if you have asymmetrical routing. But BCP38 just says, okay, I know that I should not receive packet I should receive only those sources from that link. It says nothing about where I route packets for those destinations.
Okay, I cannot imagine, as I said, but if you can, I mean, for me it's harder to imagine that, but if you can come up with a diagram on which, the BCP38 will work just fine, but this wouldn't, I mean, I'd like to see it. I mean, I might be wrong.
Yeah, the only comment I'm going to say is we really should stop talking about BCP38. Call it anti-spoofing. There's BCP84 that deals with the asymmetric routing issue. And actually, Pekka Savola had written a draft that expired, but had really good content in it, where he had operational experience with anti-spoofing a la BCP38 or ingress filtering, right, using asymmetric routing. So I think we should take this conversation to a whiteboard.
Yes.
Right, but I very much also agree with Eric that I think this might be problematic, and really, looking at all kinds of error messages that may have different addresses, and looking at what you might want to do with it differently or filtering scares me. But let's I think we should take this offline.
Yeah, and Igor Gashinsky, Yahoo. Your scenario is awesome if you are a last mile access provider. If you're not a last mile access provider and you do URPF strict, you should be fired. You're suggesting URPF strict, essentially.
No, what I'm saying is that the scenario in which we are thinking about applying this is on the edge. So that's...
What is an edge? Because an edge could be the guy one hop up from a DSL modem, or an edge could be the guy one hop up from a DS3 connected customer. They're both edge. Case one, you absolutely should be doing URPF strict, and this will work beautifully. Case 2, you do that, oh my God, you're going to break things.
Yeah,
that is why URPF loose was created.
Uh-huh.
And what you're suggesting doesn't work with URPF loose type
Well,
stuff.
actually, when you look at the rules that we specify in this document, is exactly the same thing that you find in the BCP 38, just applying, the filtering to a different field.
The problem is it doesn't work that way. BCP.
Yeah. So, AD here. The problem is it can't be universally applied the way it's described in BCP 38. If it could be, everyone would use it everywhere and things would be hunky-dory and this would never be a problem. But it can't be, so it isn't. And so everybody who says, just use BCP 38, it's like that doesn't work if your transit customers are multi-homed, like even if they are edges, because they might withdraw a prefix that they're advertising to you and still want to send traffic outbound on that link. And that causes a black hole every single time if you do strict.
Right. So, this is a great idea for access, for last mile access customers. This is terrible for anything else.
But we're not saying where to apply this, just to make the point clear.
Right. So you're saying,
saying
please apply this, unless you're saying use your discretion and hell, past that.
So
you need to specifically say where you can apply this so it doesn't break. And I'm saying that the only place this applies is one hop up from a PC.
Right, so this is a great suggestion, right? Which means that when we take the conversation offline, or even on the list, we can make some suggestions for actually some text, right? That would then say, this is useful in this environment, absolutely do not even consider it here.
Yeah, like anything that speaks routing protocols, do not even think about putting this there.
Yeah. So I think we had an interesting discussion there. There's definitely, a little bit of work on this piece of work document. So, thank you. So we're almost at the end. Did everybody fill in the blue sheet? Or the people? Where are the blue sheets, by the way? Everybody sign it? Yeah, please. Okay, so I think we're, full to the agenda then. So you have about 20 minutes back in time, which means an early break today. Thanks.
Igor, you know, just and he said something nice. You liked your work, man.
I do like your work. It's true.
Oh, here you go. Awesome. Are you on the OPSEC committee?
No.
Okay. But when, if you don't mind, when we're working on updates of this stuff, I might.
Yeah, shoot me an email.
Yeah,
Yeah.
awesome.
I'll subscribe to do the update.
Okay. Thank you so much.
Oh, anytime. Thank you.
I found a piece of paper. Do you want me to draw it? Million scenarios. It's for minute takers and JavaScripts. One, right? You have the router. Two internet links, surprise, surprise. And I send, and you receive packets to this host. And inside, yeah, there is from 2, yeah?
That's in the embedded page.
Yes.
Yes.
But because of how your dynamic routing works, you choose this route to.
Let's see. But wait, okay.
Because you send packet like this, but somewhere in the internet router
Well, but
chose.
in this case, you shouldn't be applying this checking here.
You should. Another scenario you
I mean, you know that you are multi-home here, so.
Another scenario is when your host is multi-home, you have host, yeah? But host has another internet link.
Yes.
So
Single IP address or two different?
Single.
So same IP address, you just have two links but have a single address?
Yes.
Okay.
Yes, because it might be like, you don't know actually what's happening. You think it's a home, but okay, and it sends the packet that way. But because of how routing is in the network, it's asymmetrical. It's almost always asymmetrical. It came that way.
Yes. So where would the filtering be applied in that case? Where's the device that is applying the filtering? Here.
This one.
So sorry, but what's the host and what's the router?
So okay, let me draw it. So okay, yeah, so this is better. So you have 1 root 1 2, right? And because they're multi-homed,
Yes.
there is an internet link.
So you are applying the filtering here?
Here.
Well, no, you shouldn't apply this here.
It was your picture. It was exactly your picture.
No, but it wasn't multi-home.
You don't know. How do you know?
Well, but that's the same thing when you apply BCP serially.
No, because in BCP38, all you have to ensure that all packets coming from here is from subnet L1 and from subnet L2. That's it. How they send, if they send it through another link, that's okay. They just have to make sure packets from them, from well-defined subnet. That's it. There is nothing with BCP38 here. BCP38 just say, I have 1 here, so I'm only accepting this prefix here, packets with this source here, and packets from this source here. That's it.
What you are saying that in this case things are more tricky because we are not talking about the original packet that the host sent, but rather as a response to that
and
packet?
response could come completely from you assume that your packet and the response always going through the same, they're symmetrical. In internet traffic is mostly asymmetrical.
Okay. Well, how would you phrase, because I understand what you say, I wasn't expecting this filtering to be applied in this sort of scenario.
But the problem is you do not necessarily know what is, you think it's just a LAN and suddenly it's multi-home. We just talked today that ISPs like to protect internet from their customers and their customers from internet. And they start applying filtering. And when this customer suddenly gets multi-home, it finds, oh my god, nothing works. Why nothing works? And especially ICMP filtering, it's quite funny to troubleshoot.
Well, but let me look at the scenario that you have here.
So you assume they're always communicating through you. It's not necessarily the case.
So this is the router. Where
Yes.
is the host connected here? I'm kind of like lost.
Horrible and drawing. So you have host 1. This is the LAN or whatever router. 1, 2, host 2, internet, and they also might talk to each other like this.
Okay.
And they install default routes like this at some point, right?
Okay.
One of them install default route like this. One of them. Host 1 send packet here, right? Received, but this host has default here, so it sent and you thinking, oh shit, this. Oh no, sorry, not like this. How can I draw it?
This one?
No. Yeah. Exactly. So H1 router, LAN, H2 internet. They connected like this, right? They have defaults pointing here. So this is their backup. They don't want normally use it, yeah? Packet went like this, right? ICMP reached this router, return packet reached this router somewhere in the internet, and because they have routing policy, they decided to send this ICMP back here, not through another link.
Well, but okay.
And your router actually receiving ICMP with embedded packet, which was from host 1 to host 2, and say, my God, I have host 1 here, but
in this case, in this device, since you are having this leaking here, you shouldn't be able.
It's exactly your picture. It's exactly your picture.
No, in my picture, you don't have the thing that you are putting here. So in my picture, the router that is applying the filtering knows that this host has a single connection.
How does this router know?
Well, that's the basis on which you apply the filtering. So, for example, let's say I can give you an example. Let's say that
It is exactly what I'm talking about. You cannot assume. You think that you host on one connection, and then suddenly your host gets other connection, and so now what? They have to go and tell you, listen, you're blocking my
I can give you let me think of a different scenario. So let's say that.
You see, you're suggesting something potentially dangerous to cover one is very interesting scenario, which is basically caused by the host issue.
Let's say that we have host
I believe you there are scenarios in which this might work, but the number of those scenarios comparing to the number of scenarios when it does not apply and when it's dangerous are so high and risk is so low, so I think we should concentrate on fixing stack. You know, all these firewalls like with DPIs they're looking for sessions, the packet should match the existing session. It could be done there, yeah. But it's nothing related to routing.
Okay, I see what you're meaning.
So your firewall, which sits like, in the same subnet as your protecting host, and has all this session table, and looks at all these sequence numbers, match, and all that stuff, this should look in such a CMP and say, I don't have session for this packet. Oh, I should not probably, because it's the same as receiving TCP packet which doesn't belong to a session, it just has ports and IPs match, right? It's your firewall, stateful firewall might do this stuff, but nothing related to routers.
Well, but if it's a firewall, a stateless firewall.
Stateful firewall.
No, I'm saying a stateless firewall connected to the same subnet, you could apply this, even if you don't need to go for the matching state.
No, because it's so. Again, it's very particular scenario when you know that it's only subnet and all this case. Even for stateful firewall, remember, people normally do like all this cluster with synchronization to make sure asymmetrical route packets could pass through, right?
For example, let's say you have this hosting here, right? and let's say that this host has, two routers in here, right? Now, as if the host has a single, let's say that this one is doing BCP 38.
Yeah. And BCP 38, you basically statically configure. I know that I have this subnet under this link, and I am only accepting those prefixes. That's it.
What if, let's say, just a second.
BCP 38 very easy to apply close to the host, but it's very hard to apply on as soon as you have, if you are transit provider. That's why we never managed to get it deployed universally.
What if, because this is something, I don't know if, I don't think this is flagged as BCP 38, but I've seen this done. Let's say that I have, let's say that we have, let's say 192.68/ let's say 16, right? Now, I have this connection, and let's say that this router now has a packet that is coming from this address.
No,
I know
it's anti-spoofing filtering.
Yes, but in this, there are cases in which they drop these packets because they say, well,
and they do it only normally when they know that because.
Well, so what I'm saying is that this kind of filtering that I'm saying here.
It's completely different because if you look how routing works, it's completely different. Because there is no scenario when this packet should come from outside.
Well, no. I mean, what if you have another link? Let's say that you have a network here, and
the
there's
way,
another link and comes this way.
Yes, by the way, because and they never and normally they don't drop it like if there is another network here. They do it on the like internet and how do you describe them? Let me think how I should.
So you see the scenario that I'm referring to.
Yeah,
right?
but it's completely different scenario. That's why we do this, but I would never do this because.
But what I'm saying is that in this case, I'm not saying that it's exactly the same thing, but you have a scenario where if you apply this filtering and the host is multi-home, you are breaking the network. I have a network here with two links. Now I'm sending the packet, and for routing reasons, it ends up coming this way. You drop the packet when you shouldn't. You know what I mean?
No. Okay. Let me think how I shall draw the picture, but no, it's different.
I'm not saying, I mean, you might have a scenario, I might be missing something. What I'm saying is that I've seen this kind of filtering applied.
Yes, I have this applied. It's completely different scenario.
But if this node is multi-home, then we'll be dropping this packet and we'll be breaking the network.
Yeah, I mean, it's pretty case you basically showed and say, I'm